Hi everyone. Let's begin in 10 minutes. I just wait for some folks to join if they're joining, and we'll just begin in 10 minutes, right? So let's get started. So I believe this week is slightly out of the convention for most of you folks who would have done some basic networks. So now we are moving into the realm of software-defined networks. So this is something new. This is also a research topic that's still a very hotly contested area where people are coming up with new concepts and new ideas. So in the videos, you must have noticed and you must have seen that it was beautifully explained how the SDN concept came up, and one of the key areas for SDN was basically the need. What is the need for SDN, and oh, how it led to the logical separation of the control plane and the data plane, and how what is the current status, right? This is what you'll understand in this advanced computer networks course. Where is networks right now? Where is the research going on? And how can you possibly um, um, contribute to it, right? So I'm assuming you've all seen the videos. If not, go to the videos, see it, and then you come back to it. Now we'll directly jump into the questions, and then if there are some answers, I mean, that need explanation, I'll give it on the fly. All right. So generally, we the last lectures we saw something called network softwareization, right? Network softwareization, right? So this is using CPU-based algorithms to shape network traffic. And from that, we've moved on to SDN right now. So SDN is properly explained. But then again, though this session is going to explain some questions and some answers. And if you have any doubts, you can definitely ask it in the chat, or you can raise your hands, or you can unmute and you can speak. Right. So this is more of a discussive session where if I'm missing some points, you're free to add on to it. Right. So yeah, which are the following is/are the functionality of the control plane? So there is this data plane and the control plane, right? You must have seen now.
Hello, sir. Can you share your screen?
Oh wait, what?
Can you just share your screen? I'm not
Yeah,
able to see.
you're not able to see it. Oh, I
Yeah.
think I am sharing the screen. Let me reshare it. Hold on. Hmm. Okay. I'm stopping my share right now. Let me share it again. Are you able to see anything now?
Yes, it's visible now. Thank you.
Oh, okay, cool. Good, thanks. So we've seen some. I mean, you must have seen a diagram which was something similar to this, and there was a control plane, correct? Data plane. There is a controller, right? So, and this controller tends to control what happens to these switches, right? How these switches behave. The controller tends to give directions. How it gives directions and what it influences, we look at it as the questions come on. But this is generally how SDN is basically. It's got a central controller, and the controller tends to control the behavior of the switches in the data plane. So, what do these data plane switches do? They are mostly dumb in the context of SDN. So they get packets in, and then they check their table as to where this packet is supposed to go, and the packet is put onto that particular link. That's what happens. It's the usual mechanism that has been going on in the previous classes also. But what the difference here is, this controller here, it has visibility over all of these switches. So now it knows there are 4 switches here, and these 4 switches are handling this much of traffic. So it can suddenly say, at let's say at 12 o'clock in the night, it can say, it can send a rule here and change the table entries such that the traffic will go through here and not through here. So this is done with respect to demand and traffic and all that stuff. So, but the point to note here is you are able to control how your network behaves from a centralized viewpoint. So this controller has view of the whole network here. Right. So this is essentially what SDN is in a nutshell. Right. So now how this message is sent to change the table values. Right. So this is where something called open flow comes in. Now I'm going a bit fast here because I'm assuming you've seen the videos. If in case you have not, you can ask me to go slow as well. It's completely fine, right? So again, there are switches. There is a controller. Controller controls these switches, and the controller. How does it control the switches? It does it by modifying the table. And what is the protocol that it uses to modify the table? Something called OpenFlow. That's all. That's pretty much the nutshell of this. Is what you're supposed to know. Right. So now let's go to the questions. So which of the following are the functionality of the control plane? So this is the control plane. What is the functionality of it? Is it directing a packet to an outgoing link? No. So a data packet, data packets are in the data plane, by the way. So to an outgoing link, that's the job of the router. So no, this is not. A is not. Individual router creating a forwarding table. Yes. So this table here, right? This is called a forwarding table. So this forwarding table is created by the controller, or rather, can be modified by the controller, or created by the controller, and that's what it's called. So yes, so this is true. And individual routers using a forwarding table. Yes. So when it comes to the forwarding table, oh no, this is not the case. This is not of it. This is not of it. Individual router using a forwarding table is the function of the data plane. I mean, the router uses it, right? So this is not something the control plane does. It just creates the forwarding table, right? Okay. So computing paths, the packet will follow. So again, this is also control plane because the controller tends to have a view over the whole network. So the controller can basically tell which paths to be taken by which packets. So based on that, it'll populate the forwarding table, right? And so it's basically it has a whole view, so it can control. It can like, okay, these set of packets go left, this set of packets go right, something like that. Right? So the answer is B and D. Right? So which are the following messages did the OpenFlow controller receive from the switch? Okay, just a little bit of context here. So again, I'm just redrawing the diagram here. Control plane, data plane. This is the OpenFlow controller. Right? This is the OpenFlow controller. And these are the switches. Okay. Now, as I told you, the controller tends to control the switches. Right? How does it control? It controls it using something, a protocol, and the protocol is called OpenFlow. So what is a protocol? A protocol is a set of rules. So who defines these set of rules? Us humans who create these technologies. So the person who created the person or the organization that created OpenFlow defined OpenFlow to be a set of messages. That's what it is. A set of messages which is exchanged between the controller and the switch. Correct. So either a message can go from the controller to the switch, or it can go from the switch to the controller. These are the two directions that OpenFlow defines. The question is, which of the following messages did the OpenFlow controller receive from the switch? So any packet that is being received from the switch is in this direction, correct? So this is the direction we're talking about right now. This direction, right? So it is always with respect to the controller. So any packet that goes from bottom to top or south to north is supposed to be a packet in. So this is called a packet in. Why is it called a packet in? Because it is with respect to the controller. The packet is coming to the controller, into the controller. So what is packet out? This is packet out. Correct. And what do these packets contain? These are control messages that will add add some table values or something like that, or tell the switch to do something else, or send the table details and all these details that we don't have to go into right now. Like basically packet in, packet out. So the question is, which of the following messages did the OpenFlow controller receive from the switch? So what will it receive from the switch? Simple, right? Packet in. And then there is also one more thing. There is something called port status. So this is a message, it's another kind of message where the switch will tell the controller what are the status of my ports. Okay. So again, let me write out. Packet out is controller to switch. Packet in is switch to controller, switch to controller, switch to controller, and modify state is controller to switch. Okay. So the details are there in the details are there in the video. So the answer is B and C for this. Again, it's the converse of that previous question here. Which of the following messages are sent by the OpenFlow controller to the switch? This is the north to south. So north to south, let's see, north to south is yeah. So configure and port status is south to north. Flow removed is also south to north. Modify state, correct. So modify state, what it does, it sends some values to change some state in the switch. So A and D are the answers for this. But you understood the concept, I hope. Basically, what are these messages? And the specifications, you can see it on the videos. Right? Okay. So which of the following statements is /r correct? Central control means a single API for the network rather than an API per box. This is true. Because there is a single API is application programming interface, but if you want to look at it, imagine there's a single method for controlling all of these switches. A box is basically a switch. So it's a single API. So it's not like I have one kind of OpenFlow to communicate with A, and then to communicate with B, I have another type of OpenFlow. No, it's a single API. So that's pretty much what this is. So the A is true, and SDN architecture decouples forwarding and control plane. This is also true. How does it decouple it? Forwarding is nothing but data plane. Control plane is on the top, so it abstracts it, right? It separates it. So it decouples both of it. So that's the simple answer to this. So SDN architecture couples forwarding and data planes? No. This is false. Traditional network architecture decouples network control plane from the data plane. Nope. So the answer is A and B. So consider the following statements about the SDN controller and then determine which of the following statements is/are true. So northbound and southbound. So this is control plane, data plane. Anything that goes down is southbound. Anything that goes up is northbound. All right. So southbound APIs that relay information between the controller and the individual network switches. Okay, they are APIs. Southbound APIs are those which relay information between the controller and the individual network switches. This is true. Simple, right? Northbound relay information between controller and the network controller applications. Right. So I kind of abstracted this information from you. So we have network control applications. So these applications could be anything like, let's say, one application could look at routing, or maybe one can be a firewall or something like that, right? So this controller, right? It acts like an interface between the applications and the switches, which is in the south, which is in the data plane. So it so the controller, or nothing but the northbound APIs, when it wants to communicate with the network control applications, it sends the data north. So this is northbound. So that's where statement Q is also true. Right? So R, southbound APIs relay information between the controller and the network control applications. No, this is false. So the answer is C. Right? Okay. So the following statements is/R false about open flow messages. So asynchronous messages are sent from the switch to the controller. Asynchronous messages are sent from the controller to the switch. So this is true. Let's come back to it. Symmetric messages can be sent both from the controller and switches. Symmetric messages are usually used for diagnostic purposes between controllers and switches. So essentially, symmetric messages are those which can be sent in either direction, right? It doesn't matter. I mean, there are similar messages that can be sent from the OpenFlow controller to the switch, or from the switch to the OpenFlow controller. But there are some asynchronous messages which are sent from the controller to the switch. Correct. So this could either be for to denote a packet arrival or switch state change. Let's say. So these are asynchronously sent, meaning it doesn't have to follow a synchronous pattern. The controller can send it at any point of time, right? So such asynchronous messages, they always originate from the controller. Right? That's the point here. So it should be from the controller to the switch. This is the uh, uh, wait a second. Okay, so it's supposed to be the converse of it. Right. Yeah. Sorry. So it's the converse. Whatever I said, it is the converse of whatever I said. The asynchronous messages are sent from the switch to the controller. correct? This is also true. This is also true. This is false, basically. So controller to the switch, it is not sent. So it is the other way around. All right. So just putting it out there. The rest of the concept remains true. So this one is for this. So which of the following are types of symmetric messages? Which is this is again once again OpenFlow basics. A and C. Hello and echo. Right. I mean, these are very theoretical questions which you can find answers to in the videos of this week. Okay. So consider the following scenario. Packet P arrives at switch S and does not match a flow entry in any of the flow tables that switch S has. Okay. Which message type is then sent to the controller C by the switch? So a packet and message is sent. So this is basically how OpenFlow is defined. So essentially, when there is a switch and there's this controller over here, the switch gets a new packet, let's say, a packet from a new flow. So the controller has to be informed of the fact that a new kind of packet has arrived. So what does it do? It sends a packet in of the same packet that arrived to inform the controller such a new packet has arrived. Now, I don't have a flow entry. What do I do? So the controller says you send this packet to this direction A or B or something like that. So that's what a packet is, and that's what happens when this scenario occurs. Okay. Again, a packet in is when a packet is sent from the switch to the controller. This direction. So which of the following is true about SDN deployment? SDN-enabled networking devices, which are routers and switches, can coexist with traditional networking devices. Yes, it can. SDN-enabled networking devices cannot coexist. No, it can coexist. So this is false. Traditional networking devices cannot be transformed to SDN through firmware/hardware upgrade. So this is also a very dicey statement, but consider this as false for now. Um, I mean, it's transforming it to an SDN. Uh, Transforming it to an SDN device may not be possible in all scenarios. So probably this is a dubious statement, but for now you can just keep it as false. Right? SDN enabled end hosts do not need ARP, RARP. So see, ARP and RARP are two different, completely different aspects. So they have nothing to do with SDN as it is. So they still need ARP, which is address resolution protocol. And when is it used? It is used to get the MAC address. So the IP address of a particular item in the of a particular device in the network. This is also false. Right? Okay. So which of the following is incorrect about SDN? So SDN is about decoupling the network control plane from the network data plane. Is it true? Yes, this is true. Yeah, this is true. SDN is about providing logically centralized control over data plane. Yes, this is also true. It's a logically centralized controller, right? So SDN enabled end hosts can take advantage of SDN controller to do routing. No. Why is it false? Because they're talking about end hosts. End hosts cannot take advantage of SDN controller at all. SDN controller has everything to do with the switches in between. End hosts are over here, right? Controller only has to do with the switches in between, the network in between. This is false. SDN is to remotely control and configure the forwarding behavior of the network device. This is also true, right? So you're able to remotely control these switches, and you're able to control their forwarding behavior, right? So this is also true. So to the following is slash are considered the pillars of network softwareization. So network softwareization, uh, it's about using CPU-based approaches to getting network functions, right? Which can be run on CPU-based devices. So which are the following are considered the pillars of network softwareization? So it is network virtualization, which is B, and SDN and network function virtualization. It is B and C for the first one. So basically operating systems and compilers is a very generic statement, so we don't have to consider this. 5G networks and massive MIMO, this is also something that's not related to this. These are the two things that uh, make up network softwareization as it is, right? So which of the following is slash are considered as the functionalities of SDN control plane? Forwarding a data packet to an outgoing link? No. Setting up flow rule for an incoming packet? Yes, correct. So how does it do it? By using a packet in, right? Dropping of a data packet when ingress or egress queue is full? No. Who does this dropping of data packets when ingress or egress is full? This is basically done by the switch or the data plane device itself, not anything, not anything else. Right? Computing paths packet has to follow. Yes. So this is kind of a repeat question from what we solved previously. So the answers are B and D. Yeah, I'm just breezing through these questions because they're all mostly theoretical, and you can also follow through if you see the videos and then come back to this again, right? So which of the following is slash are considered the functionalities of SDN data plane? Um, Forwarding a data packet to an outgoing link? Yes. Buffering and marking of packets? This is also yes. So if you saw in the previous classes, we saw traffic shaping, traffic policing, right? So there you sometimes also tend to mark the packets. Let's say it's an ECN packet, you mark the ECN notification message on that packet, right? So so B is also true. It is done by the data plane. The controller cannot mark packets. It can only tell what to do to the data plane or the switches. Traffic shaping and scheduling of packets, yes, is also done by the data plane, the device in the south. Computing paths the packet has to follow. This is done by data plane. So it's in the control plane. So the answer is no. The answer here is A, B, and C. Okay, so fourth question is which of the following messages does the OpenFlow switch receive from the controller? Um, Kind of a repeat question. So packet out and the modify state. We saw, right? Like packet out is when the packet goes out from the controller. So where does it go out from the controller? It goes to the switch. And modify state, it is the controller telling the switch to modify some state in its table or in its configuration. Which of the following messages does the OpenFlow controller receive from the switch? So from the switch, once again, this is again I think a repeat question. The answer is B, port status, and C, which is flow removed. So essentially, these are all some messages which tell the controller that a flow has been removed, or to inform the controller of the port status. So what is the status of the ports? Are they up? Are they working? How many ports are there? So these are the two messages that these are just some of the messages. Not all of them have been specified. You can look at the video for a list of all the kind of OpenFlow specifications that could be a question could be asked on. But this looks like a very ripe area for questions to come from. So which of the following statements about SDN are not correct? Okay. So central controller means a single API for the network rather than an API per box. Okay, they are not correct, right? This is true. SDN architecture decouples forwarding and control planes. This is also true. SDN architecture couples forwarding and data plane. This is false. And SDN controller is a single point of failure. Okay. SDN controller is a single point of failure. So in the classical sense, yes. But if you take a controller is not just one computer that's working, it's a set of computers that work. So there is a set of amount of fault tolerance that is built into a controller. So it's not exactly a single point of failure. So this is also false. So the answers are C and D. Okay, so which of the following statements about disaggregation with SDN slash R correct? So white box model enables both open source hardware and software. Black box model enables open source software to run on proprietary hardware. Bright box model hmm, enables running proprietary software on open source hardware. Right. Okay. So white box model, it enables both open source hardware and software. This is true. Black box model enables open source software to run on proprietary hardware. No, black box means the switch or the network device. You cannot program it. It is already programmed by the vendor. So you cannot run your own open source software on it. It's not like a computer. It's not like a computer that you buy and install your own software. It is already installed for you. So if you're buying a, let's say, your Wi-Fi router, the software in it is already existing. So you can and you cannot change the software, right, or the operating system or the firmware. But if you buy an OpenWRT compatible router, you can flash your own ROM to it. You can change the software in it, right? So that is a white box model, which uh, allows you to program it. The black box model makes you feel restricted in the sense that you cannot do anything to it. So this is false. So bright box model is something that enables running proprietary software on open source hardware, and it also enables running open source software on proprietary hardware. So this both of these are true. These are just the way in which these network devices are set up, right? So there are some kind of devices which are white box, which are black box, and which are bright box. So A, C, and D, all these three are true. Which of the following statements is slash are not correct about OpenFlow? So OpenFlow is one of the implementations of a southbound interface. Yes, this is true. Because you send messages from the controller to the switch. OpenFlow covers both northbound and southbound interface. No, false. OpenFlow includes both synchronous and asynchronous messages. Yes, this is true. Symmetric messages can be sent both from the controller and the switches. It's also true. Correct. So the reason why northbound is not included, right? So as there are you see this diagram. I think I might have confused you before. There is a controller, and there is a network control application, right? And these are switches. So generally, anything above controller is northbound, and this is southbound. So in this model, the statement B is false. Right? So this is, and please consider this. The previous one that I explained was just for the sake of ease. Probably that should not have been done in that particular fashion, but keep this in mind, all right? From the controller to the north is northbound, and this is the southbound APIs. So southbound APIs include both messages that go from this direction to this direction, and as well as this direction to this direction, right? Anything below controller is southbound, anything above controller is northbound. In that sense, this answer is B. Which of the following are types of asynchronous messages? The answer, one of them is A, right? So, I mean, this is packet in. Send config, feature reply, and packet out are not asynchronous messages. Which of the following actions are not supported in OpenFlow? Forward packets to specific switch port. Yes, it is supported. Drop packets. Yes, you can instruct the switch to drop packets. You can modify, add, and remove VLAN tag. Yes. So VLAN is like a mark on a packet. You can remove that particular mark from a packet if you want. IP fragmentation and assembly. So this is something that is concerned with IP layer. So the OpenFlow controller does not have such kind of granular control over how the fragmentation and assembly happens. So it is not concerned about that. It only takes a decision of what to do when a packet comes. Drop it, forward it, if forwarded, where to forward it to. So the answer is D. Right? Okay. So I think, yeah, this is pretty much what we have for this week in terms of the theory that has been taught. I'll be here for another 10 minutes. If you have any questions, you can ask me. If you don't have any questions, you're free to leave. And I'll put up the recording on YouTube, and you folks can watch it if you want. Right. So again, as I say, I mean, probably repeating what is already there in the video is probably is not the best utilization of time, because it's already there in the video, and I can engage you if you have any particular questions about some topics in the video. I'll be happy to explain. Uh, if not, we'll follow this model of just solving questions, 20 questions every week, so that you can it can be easier for you to answer your end exam, so whatever, right? All right. So that's it from my side. If you have any questions, you can ask me. Otherwise, you can leave. Thanks, guys.
Hi, Adit.
All right. I'm ending the call. Thank you.